Hi everyone. In this video, we're going to look at compound angle formulas. Now, compound angles are angles created by adding or subtracting two or more angles. Let's say we had two angles, A and B, and we added those two angles together. Then, we could express the sine, cosine, and tan of A plus B. For example, sine of A plus B is equal to sine of angle A times cosine of angle B plus cosine of A times sine of B. Similarly, if we took those two angles A and B and we subtracted them, we can express the sine, cosine, and tan of A minus B. Let's take a look at some examples of how we can apply the compound angle formulas. In this first example, we want to use a compound angle formula to find the exact value of sine of pi over 3 times cosine of pi over 12 minus cos of pi over 3 times sine of pi over 12. Well, if we think back to our compound angle formulas, this looks similar to this compound angle formula. Here, angle A would be pi over 3, and angle B would be pi over 12. So that means all of this simplifies to equal sine of A minus B. Or in other words, sine of pi over 3 minus pi over 12. And we can simplify this some more, right? Because, okay, pi over 3 minus pi over 12. If we write this so that it has a common denominator, right? Well, pi over 3, that's going to be the same thing as 4 pi over 12. And pi over 12 would stay the same. And now, 4 pi over 12 minus pi over 12 is just 3 pi over 12. And 3 pi over 12, we can simplify that some more. 3 pi over 12 simplifies to pi over 4. Now, to find what sine of pi over 4 is, we can use one of our special triangles. And specifically, we want to use a special triangle that has the angle pi over 4 in it. So I'm just going to draw out that special triangle. And now we can see, remember, sine is opposite over hypotenuse. So that means sine of angle pi over 4 is equal to the opposite, 1, divided by the hypotenuse, square root of 2. And that's my final answer. Okay, let's take a look at another example. Here, we want to use a compound angle formula to find the exact value of sine of pi over 12. Now, this angle, pi over 12, is not in one of our special triangles that we've looked at. But there's something, but we can, so we can use one of our compound angle formulas here to help us out. Because if we can express our angle, pi over 12, by adding or subtracting one of the angles, say, inside our special triangle, then we can figure out what sine of pi over 12 is. So the idea, again, here is we want to figure out what two angles add or subtract to give me pi over 12. Right, and if we can find two angles that work nicely, then we can use a compound angle formula to figure out what sine of pi over 12 is. Okay, well, pi over 12. Well, I know, for example, 4 pi over 12 minus 3 pi over 12 is equal to pi over 12. Okay, 4 pi over 12, that simplifies to give me pi over 3. And 3 pi over 12 simplifies to give me pi over 4. And guess what? These two angles, pi over 3 and pi over 4, they are in my special triangle, right? So we can use this to help us figure out what sine of pi over 12 is. Okay, let's keep going. So sine of pi over 12 is going to be equal to sine of pi over 3 minus pi over 4. And now we can use our compound angle formula for sine of a minus b, right? Because we're subtracting two angles here. And that formula tells us that this is equal to sine of a times cosine b minus cos A times sine B. Here our angle A is pi over 3 and our angle B is pi over 4. And now, if we plug those angles into our formula, we'll have sine of pi over 3 times cos pi over 4 minus cos pi over 3 times sine pi over 4. And to figure out what this is, again, we can use our special triangles to help us out. Okay, so here, to find sine of pi over 3, we'll need to use our special triangle with the angle pi over 3. And I'm just going to draw it out here. Okay, if we use our special triangle, we'll see. Okay, sine opposite of our hypotenuse is equal to root 3 over 2. To find cosine of pi over 4, we'll need to use our special triangle for the angle pi over 4. And here we can see if we use a special triangle, that cosine of pi over 4 adjacent over hypotenuse is equal to 1 over root 2. Okay, minus cosine pi over 3. Again, adjacent over hypotenuse, that is, if we use a special triangle here, that's 1 over 2. And sine of pi over 4, if we use a special triangle here, is 1 over root 2. And we can simplify that some more, right? Because here, if you look at this on the left, root 3 over 2 times 1 over root 2 is root 3 divided by 2 root 2. And here, 1/2 times 1 over root 2 is 1 over 2 root 2. And now, since my denominators are the same, I can just add my numerators together. So my final answer is going to be root 3 minus 1 divided by 2 root 2. Let's take a look at one more example. Here we want to find tan of 5 pi over 12. Again, the idea is we want to find two angles that add or subtract to give us 5 pi over 12. Okay, let's see. So one thing we could do is 3 pi over 12 plus 2 pi over 12. Okay, 3 pi over 12, that simplifies to give me pi over 4. And 2 pi over 12 simplifies to give me pi over 6. Okay, these angles are on my special triangle, so we can use them to find tan of 5 pi over 12. Okay, so now we can use our compound angle formula for tan to figure out what this is, right? Because our compound angle formula for tan tells us that this is equal to sorry, let me write down the angles first. This is equal to tan of pi over 4 plus pi over 6, which is equal to, based on our compound angle formula, tan of A plus tan B divided by 1 minus tan A tan B. And now if we replace angle A here with pi over 4, and angle B by pi over 6, okay, there we go. There's our compound angle formula. And we can simplify this because, okay, tan of pi over 4. Again, let's think back to our special triangles here. So tan of pi over 4. If I draw my special triangle, I'll see tan of pi over 4 is equal to opposite over adjacent, or 1 over 1, or just 1. Tan of pi over 6, again, if we think back to our special triangle, tan of pi over 6 is opposite over adjacent, or 1 over root 3. Okay, so we just plug those values in. And in the denominator, I have 1 minus tan of pi over 4. Again, tan of pi over 4 is just equal to 1. Times tan of pi over 6, which is equal to 1 over root 3. And now, just like before, we can simplify this. Because you'll notice in my denominator here, I have 1 minus 1 times 1 over root 3, which is just equal to 1 minus 1 over root 3. And we can simplify this some more. So you'll notice in my denominator, right, if you look at the fraction here in both my numerator and denominator, they both have my fraction 1 over root 3. They both have a denominator of root 3. So what I could do to simplify this is I could multiply the top and bottom by the square root of 3. Because if I do that, this will help me cancel. This will cancel out my denominator, root 3. Okay, let's simplify this. So if I multiply out the top, 1 times root 3 is equal to root 3. 1 over root 3 times root 3 just gives me 1. Divided by, okay, in the denominator here, 1 times root 3 is equal to root 3. And negative 1 over root 3 times root 3 is equal to negative 1. There you go. There's my answer. So, the idea when we're trying to find the exact value of different expressions like this, well, all we're doing is we're trying to figure out, okay, what two angles add or subtract to give me the angle inside my brackets here. And usually we want to pick two angles that we know how to deal with. So for example, those could be angles that are in our special triangle.